In coordinate geometry, our objective is to be able to find distance, length, midpoint, endpoint, and slope in a coordinate plane. Let's start with finding distance or length. For example, find the distance between points r, -6, -2, and s, 4, 3. Another way this can be asked is find the length of segment RS. Keep in mind for length or distance, you're doing the same thing. We're going to use Desmos for this example. We're going to type in the points and the command distance r, s like this. I've already written for you what it looks like when we type the r in, -6, -2. Next, we would type the s in, 4, 3, write it in so you have a record of what you're studying today, and then distance of the 2 points. Notice because we used capital R like they gave us and capital S like they gave us, we're going to type in capital R and capital S. Let's go ahead and we'll see how that looks in the Desmos program. I type capital R equals parentheses -6, -2, close parentheses, and I like to click Label, just like I showed you here, so that I can see it in the graph. In the next cell, we type capital S equals 4, 3, and again click Label, so I can see it in the graph. Next, we type distance, just the word, no capital letters, open parentheses, and then using the exact same letters we typed in up here, R, S, the Desmos calculator tells us the distance between the points, also known as the length of the segment, 11.18, and I'm going to have to round here. Let's go ahead and jot that down. 11.18 is what we got for the distance. Now, if I'm given choices, I need to choose the choice that is exactly the same. If it's necessary, I type in the radicals to the Desmos calculator. Now, I notice that the first two are not the same as 11.18. This is 125, and this one is 11. It didn't say to round in the question. It wants that distance or that length exactly. So now I need to type in these two choices and see which one is 11.18. Let's get that Desmos calculator back, and we'll type those numbers into the cell. Let's move that over so we can see better. We'll type in, notice our little keypad, if it's gone, we click there, square root 125. Well, I see this does equal 11.18, but let's type in the other one to be sure, 5 square root 5. Now this one also equals 11.18. In a case like that, where both of them are 11.18, we choose the lowest radicand because that's the simplified version. The lowest radicand means the lowest number inside the radical. Since these are both the same, we choose the one with the lowest radicand. Therefore, D is the correct answer. Finding midpoints, sometimes called finding a bisector. That's important to note that it could be written both ways to mean the same thing. For example, find the midpoint between points R and S. Again, we're going to use Desmos to type in the points like we did for distance. So R we have, and S, but this time, instead of using the distance command, notice we're using the midpoint command. And just like we did with distance, however we typed those letters up here, in this case capital R and capital S, that's how we write it in that command. So going back to my Desmos calculator, I can get rid of the cells that I don't need, these computations from before. I have those points, and now I'm going to type midpoint. That's what I'm looking for. Even if it says bisector, I'm typing midpoint, R, S, and then I want to click Label. Notice this time it doesn't show me the answer here, but it shows me the answer on the graph. And I can tell that that point certainly is in the middle between these 2 points that I labeled up here, R and S. I have my answer, -1 and 0.5. I write it as an ordered pair, -1 and 0.5. If you're not sure what the decimal is and you want a fraction, you can simply type that in the next cell, 0.5, and hit the fraction button. And it will give you the fraction equivalent, 1/2. So we could write our answer as this, or we could write our answer as this. Depends on how we need to choose our answer. If we're given choices, choose the one that is exactly the same. Find missing endpoints. For example, find missing endpoint B given one endpoint A is -5, -6, and the midpoint M is 0, -2. We start by, in Desmos, typing in the given points. So we have the given points are one endpoint, -5, -6. We of course click to label it, and then we type the midpoint M is 0, -2. It's useful to highlight or underline some key phrases like we're supposed to find the missing endpoint B. We don't know what B is, so we can't type that in yet. Let's go to our Desmos calculator and type those in. So I've typed in what A equals. I click to label it. In the next cell, I type M equals 0, -2. And again, I click to label it. Now I see in my graph where the endpoint and the midpoint are. This might be helpful here to zoom in because it looks like it's at a halfway point, but it's really not. So I can click the plus key to zoom in a little bit, and I can scoot this over so I can see more of the graph. Now, I know that this one is the midpoint, this purple point is M, and I need to find the missing endpoint. So what I could do is count from the end, like I'm doing slope, up and over to the midpoint, and because this is the middle, it has to be the same distance to the other end. So if I count from this green point, I'm counting up, the rise, 1, 2, 3, 4, and then the run, 1, 2, 3, 4, 5. Let's count that again. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So I see where probably the endpoint lies. It looks like it's over 5 and up 2. So I'm going to try to type that. Capital B equals 5, 2. I'm going to click label so that I can see that point. Now I'm going to type midpoint to check that my guess was correct. I'm going to calculate the midpoint between the points A and B. A that they gave me and B that I guessed at. A, B, and then I'm going to click label. Notice that point fell exactly on top. See what would happen if I guessed incorrectly and I thought it was 5, 3? Now the point that they gave me as the midpoint is not exactly on top of the original midpoint from the problem, so I know I'm wrong. If I'm given choices, I can keep typing in the choices until I get the one that is exactly in the same spot. Let's write this information in our notes. We guessed that midpoint or that endpoint B was 5, 3, and then we typed the midpoint of the two endpoints A and B, A and B. We typed in our guess and the midpoint command. Type in our guess. That's in point B. Then the midpoint command, just like we did here with A and B. We adjusted our guess until the midpoint was the same as the given midpoint. If we're given choices, we can type them all in until we see which one works. Now I think I might have, yep, the wrong point B there. Let's fix that for our answer. We know that it's 5, 2. And that would be our answer if we were typing it in, is 5, 2. Or if we were choosing the correct one, that's the one we would choose. Let's talk a bit about slope, applying parallel and perpendicular slopes. There's the real way to do slope, And then there's the SOL way to do slope. Really, we do need to know the slope formula anyway, no matter if we're thinking about the SOL way where we use their ruler. Using the slope formula, y2 minus y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or from the graph, we can count the rise and run going up and over, or down and over, or from an equation, m is the slope. Then we apply the slope because parallel means the same slope, and perpendicular means the opposite reciprocal slope. What does opposite reciprocal mean? Well, if one slope is 2/3, the other line has a slope that's upside down and the opposite sign. That's the reciprocal. That part's the opposite, opposite reciprocal. If one slope is -5, the other slope is, since there's an invisible divided by 1, positive 1/5. If one slope is positive 1, 1 over 1 is still 1 over 1. So -1 is the opposite reciprocal. Just as a reminder, on the SOL, they give you a ruler. So if we think about the ruler being a rectangle, we're going to use the ruler where we line up seeing opposite sides that are parallel or consecutive sides that are perpendicular because rectangles have right angles. Using Desmos to find slope or graph a line, we can make a table with given points. Let's see how we can apply some of these ideas to this next example. Line T contains the points -8, 5 and 8, -3. Identify the points other than point P with integral coordinates that is on a line parallel to T and passes through point P. So some important words here that we might want to highlight: parallel to the line that they gave us and passes through point P. That's this point right here. Integral coordinates just means that it's right on any crosshairs. There's no half numbers or decimal numbers. We're going to choose from these points here. So our first thing to do is going to be to graph this in Desmos, and we can do that how I showed up here. Make a table with the given points. It will look like this by clicking the plus sign in the upper left corner and then choosing table. Let's see what that looks like. So I'm in my Desmos calculator. I click the plus sign in the upper left corner and I click table. Now I'm going to type in the points that they gave me: -8 over to the y value, 5, and then go down to the x, 8, and then over to that corresponding y, -3. In the next cell, I'm going to type y sub 1. I just have to type the y and the 1, and then the little squiggly button, which I can find on my keyboard. Even on this keyboard, I click ABC, and there's the squiggly, and then M, X1 plus B. And they show me the line. Now, I'm not zoomed out enough to see my points, so I zoom out a little bit, and I see those are the points. Notice here, the M is given. M is the slope of this line, -0.5. So being parallel and through this point, it will have to have the same slope. Now, I'm not too worried about that, but I can plot all these other points in here and use my ruler to figure out which ones have the same slope. So I can type P equals 4, -6, label it, and then I can type all the other points they gave me until I find the ones that lie on a line parallel. I'm going to label all of the points. Now I've got all my points typed into Desmos, and I can see which ones look like they line up with point P to make a line parallel to that one. I can also use the fact that the slope is -0.5 to make another table with point P and each of these points separately to see which ones have the same slope. Our SOL ruler we can pull out also. Now yours is going to look a little different from mine on the test, but it's the same idea. This is a rectangle, and the sides of the rectangle are parallel. So once I line up that ruler exactly along that line, I can then line it up along point P and see which other points also line up along that side of the ruler. Notice these two are left out, but these three are good. So I'm going to choose those points as my answers to -5, -6, -1, and -4, -2. And those are going to be my choices that I will select. Let's look at one more example. The slope of line P is -2. Point A, 5, -1, and point B, 1, n. Find the value of n so that AB is perpendicular to line P, so that the line AB is perpendicular. I remember that perpendicular lines have slopes that are opposite reciprocals, and that's going to really help me here to do this the easiest way. The opposite reciprocal of -2 is positive 1/2. And then I remember my slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That means I'm using this point, the x and the y, and this point, the x and the y. This is my first point, and this is my second point. Let's plug the y's in. N minus -1 over 1 minus 5, and that has to equal 1/2. Now I'm going to use Desmos to solve this equation. When I use Desmos, however, I do need to type in whatever the variable is. Instead of that letter, I need to type it in as an x. Let's go to our Desmos calculator now. I start by typing the divided by key to get a fraction, and then I type x minus -1, just like I wrote, over 1 minus 5, just like I wrote, equals 1/2. My solution will be shown in the graph by where the line crosses the x-axis, and it's that x value, -3. So as a reminder, to solve an equation in Desmos, type in the equation and click on where the graph crosses the x-axis. Thanks for watching.